Good evening, everyone.
Good
Uh,
evening, sir.
Good
so
evening, sir.
thank you. So this free workshop is presented to you on behalf of SkillEnables, and the topic is already known to you. For this free workshop, the topic we have chosen is time series analysis, followed by anomaly detection, and then BI in data science. All three are spread topics and they have different horizons. Now, the purpose of this is to give you a glimpse of how things works, right? Maybe some of the fundamentals explanations may not be available here in this series, but the topics are interesting and you will have a feel of it that after doing these courses, how you're going to handle this or how the professionals handle it. So this is me, Niharanjan Roy, already introduced to you by the speaker. Now, why do you feel that this data science is booming and this data science is, sorry, first 5 to 10 minutes, I will set the context. So bear with me if you are aware about the field, but let me go by my perception or somebody who is quite new. Let them also have it because there are around 80 plus participants here and some of them might not be knowing the importance as it should be. So why data science is booming these days? This is the reason. Now you see this photograph. This photograph is a 5 to 8 years old photograph, right? Now you see data is the new gold of this era. And if you see only one V, there are certain V's which define or describe the data. So one of them is volume. So 8 years back, you see 2.5 quintillion bytes of data created per day, 40 zettabytes of data to be created by 2020. 6 billion people have cell phones, and this is 100 terabytes of data stored by most of the companies. Now, this is one aspect of this data creation at that to 8 years old. Now, you assume that 8 years ago, which all devices you were not having and what you have today. And maybe starting from your smartwatches to your mobile devices, if IoT devices or something. Now, this data talks about volume. What about the velocity? Velocity refers to the speed at which data is moving, right? You have to deal with that when it is moving. It is not that it will always be stored because certain informations needs to be extracted from this data in real time. Similarly, data can be available in different forms and you may not be equipped to handle each form exactly the same way. As you say that every illness has a different medicine. So if the data is not in a particular format, your approaches, your algorithms may not work. So how to migrate, what are the challenges, data cleansing, data wrangling, transformations. These again are some of the buzzwords of today that experts use to make it presentable. Anyways, now you see the size of the data which is increasing. When I purchased my first computer, the memory in that computer was in terms of MBs. 128 MB was my 128 MB was my desktop's RAM size, and today it is around 16 GB. So 120 MB, so approximately comparison to 16,000 MB, right? How this transition has been. So you see, similarly, these terms which are not common till date in our normal life. For example, after TB, you see petabyte, exabyte, zettabyte, yottabyte. They all are going to be there in near future. Now, some more statistics, if you see, are relatively new. 4 billion active users, right? In net, 2.5 quintillion bytes created per day, 23 million emails sent. Google searches 5.5 billion, 69 million photos, 5.9 billion videos, websites hacked, Skype calls, internet traffic, and amount of electricity used, CO2 emission, and this everything is happening in one day. Everywhere, let us start that all of you have Facebook accounts, but why all of you have a different landing page on your Facebook account? You believe, you agree with me that when you log in, everybody has a different advertisement sections, different products displayed over there. Now, from where they are coming, why it is different, right? It is believed that the data that we have generated in the last 2 years is much, much higher than the data we have generated from before 2 years to the prehistoric era. Now, if this much is the data, which includes the data in the caves and others, so if this much is the data we have generated in the last 2 years, then who is going to handle it? How we are going to, it is of what use? Now, the data has multiple uses, and these things cannot be seen, or you cannot draw the information from this only on the basis of your intuitions. For example, if I tell you that if you go to a shopping mall and if you want to purchase a bread, does it make any sense to keep the butter near the bread? Yes, it makes a sense, and all of you agree to me that when you purchase a bread and you see butter, you may have a recall that, oh, in my fridge, the size of the butter bar has decreased. It is getting smaller, and I may not have enough butter for the tomorrow morning, so I should procure it. Now, keeping it close to each other has an advantage for the shopkeeper that you purchase from it and the profit goes to him. If you forget not to purchase from that shopkeeper, right, maybe you might purchase that product from somewhere else. So here the shopkeeper has an advantage, and he found a relationship between the bread and butter by analyzing the market basket analysis, what we call, from the customer's purchasing history. But can you find any relationship between beer and diapers? Yeah, beer, the drinking beer, right? You know, none of you will find any relationship. That how can there be a relationship between a beer and a diaper? But it has been found out. It has been found out by the data analysts. And how it is found that in European countries during the weekends, people like to enjoy beer, right? And they will have a whole bunch of beer cans, and they do not want to get disturbed for the duration of 2-3 hours. So what they do, they put their baby kids into diapers so that these kids do not disturb and they can enjoy the beer. So you see, this kind of experience or drawing of the conclusions can only be possible if you have the right set of skill set. Otherwise, with tons and tons of data, it is not possible to draw it. Now, see another diagram. Number of tweets, 500 million tweets every day. 4 petabytes of data created, including Facebook. 294 billion emails sent. 4 terabytes of data produced by connected cars. Now you see these cars are also producing this data. And what about these devices, wearable devices? 28 petabytes, and that too by 2020, right? 65 billion messages sent over WhatsApp and 2 billion minutes of voice and video calls. Now, why do we need to analyze it? Now, if you see this modern, whatever you called AI tools, they are coming up. From where did they learn? For example, if you talk about the Siri, Alexa, or other assistants, and they understand our voices and recognize us. So from where did they learn? From India, who were those people who went there and gave the voice samples? The reason being, whenever we speak English, you see the same sentence, same words has a different pronunciations by people belonging to different regions. Maybe someone from the northeast, someone from north, someone from south, someone from east, someone from the west may pronounce it differently. Then how these modern tools are recognizing our voices, and with that too with so much of accuracy, right? Who has given them the samples? Believe you me, everywhere it is our data which is being used. The copyright which we sign blindly, they have our data, they are analyzing it. Even the smallest stores these days, if you see, they are recruiting students for the data science interns. They go there, they analyze the customer data sets, right? When people pay tips, what is the amount of the tips, average tips, who gives more tips, boys gives more tips or girls gives more, ladies gives more tips, who gives more tips, do smokers give more tips, so that they can value their customers who is important for the business. Now, there are a number of applications where this data analysis is important. Right. So everywhere these devices, IoT devices, smart devices, they are going to generate data, right? And this data is stored somewhere, especially on the cloud, and it has to be analyzed for better serving or making life easier, right? By life easier, there could be certain challenges also, and one of them is privacy. But I will not address those aspects now. By 2026, the data science and analytics would consist of more jobs. As you see, unbeaten salary. The modern job opportunities would be in this field only, and everywhere there arise this job opportunities are arising. This data analysis has to be done. Gone are those jobs where 10 to 15 years down the line, people used to write codes to automate certain processes, right? Building desktop applications, building web pages, websites. Now, these things are already so smartly catered by the tools that it can be created within a very less time, and the opportunities are not there. Opportunities are there in the areas where the users of AI are there, right? So new job opportunities would be those who use AI, who use data science, right? So the and one more thing, see, data is required in data science. Data is required for machine learning. Data is required for deep learning. In total, data is required for AI. Data is required for governance. Data is required for experimental and research works, right? Everywhere it is going to be data. And who understands data, who can bring those insights from the data, that job is important these days. And these are modern skills. These modern skills has to be learned on time. It has to be learned on time. The person who learns it on time will have the winning edge. Now, these are some of the companies who are hiring from SkillEnable. About SkillEnable, already Sanchita has briefed you. So some of the characteristics of the classes: 100% live classes, online classes. Placement is 100%, trained by industry experts. The courses are employability focused, continuously updated curriculum, and the pattern of fees and others, 50%, that is also there. Now, success in numbers: learners in data science program, industry experts, hiring partners, highest hike in the salary, salary as high as 29 LPA you get. Learners mention career meaningful changes, 80% of them. Average salary hike is 50%. Companies that are currently hiring, right? So these are some of the statistics from SkillEnable, their partners, and how they help you to get the job. Not only once you join a data science course, they train you in the data science, but they have other supporting classes for example, aptitude, resume building, and they assist you in other things. Now, once you do a data science course, what are the job opportunities? Just to see, some of the job opportunities could be as data analyst, data science, machine learning engineer, business analyst, data engineer, data architect, data visualizations developer, big data engineer, data and analytics manager. Some of these roles are overlapping. These roles vary from organizations to organizations and company to company. Maybe in a small or a medium-sized company, you might be playing a role of any one of these or more than two roles, right? But the task that is being performed, that is important. Now, today's topic, as a part of this, what we are going to cover is a time series analysis. Now, time series analysis is a special case of data science, data analysis. Now, what is so special about it, that whatever the data that we have, that is dependent upon the time, that is logged or that is recorded on the basis of time. So we do have time as one of the parameters, and corresponding to those time units, we have the data. So formally, if you see, a time series is a sequence of observations. 1 second, please. Let me correct my pen. So time series is a sequence of observations recorded over a certain period of time. Observations, you can mean that records, right? If you have a tabular data, then the record which you have each row is known as observations, right? A simple example of time series is how we come across different temperature changes by day or in a month. So how does the temperature changes with respect to day, hours, right? This is a time series data. Time series forecasting is another terminology. In simple words, it means forecast or to predict the future value, right, over a period of time. So what is the expected time data for a particular thing? Some of the areas or application areas of time series could be weather forecasting, earthquake prediction, astronomy, statistics, mathematical finance, econometrics, pattern recognition, signal processing, and control engineering are some of them. And one more important thing is stock trading. There also it is quite in demand. Now, let us try to take an example. There are different approaches to predict a value. For example, let us have a look at a data, and this data is about web traffic. So this is a web traffic of a company at some time interval T1, T2, T3, T4, T5, and T6. Now let us see that the number of hits or traffic is 300, 310, 420, 530, and 640. So what would be the time over here? How to predict it? So this prediction as we go naturally, will be a mean of all the observations. You can say that let us take the mean of all the previous observations, and whatever is the mean or the arithmetic average, let us put it, and it comes to be around 300 or 310 to 649, 450 could be some of the approximately this value as per the mean, approximately, if you calculate. So this is one of the approach that you can follow, but this is not a suitable approach. Now, other could be take the mean of recent two observations. Somebody may say that, okay, why are you taking past data? You take the recent data and you see there is a recently increase in the trend. So increase in the trend says that the value may still be higher, but if not higher, then try to take only two recent values. And if you see, if you take their mean, then it comes to be around 1170. 1170 means 585 approximately. So this new value could be 585. So you see the difference in approach 1 and approach 2. There is a tremendous difference, and we cannot have the risk of this much of a big difference, right? Another approach could be give more weightage to the current observations and less to the past. This means why you are considering only 2 values? Why not to have all the 5 values? And maybe you will give it a weightage of say 0.1, 0.2, 0.3. 6 yahin pe ho gaya. Maybe 1.5, 0.2, 2.5. So ये हो गया 4, 5, 6. और यहाँ पे point maybe कुछ गड़बड़ हो गया क्या? 0.1, 1.5. 2.5, 2.5, 2.55, and maybe here 2.5 or 2.5. Or maybe something here, you say this is 3, this is 2. 5 यहीं पे हो गया, यहाँ पे 1, यहाँ पे 0.75 और यहाँ पे 0.5. 0.5, 0.75, 1.5, 2.5, and 3.5. This is the weightage. This means you multiply this value by this weight, and add them, and then you divide it, so that you see the effect of recent data is more on the average. The contribution of the recent data is more, and here you will find the average would be relatively better. So there are three ways intuitively, not these are the exact ways, but intuitively there could be three solutions as we can think of right now. Now, this could be your way of predicting or forecasting, right? But this is not the best way. We will see what are the other ways and what are the challenges with time series forecasting. But I hope till now it is clear to you what I'm trying to set, what is time series and what we are trying to predict, what we are trying to analyze. Right? If you have the options to raise your hands, you can raise or indicate in some way so that you guys are listening.
Yes, please.
Yeah, thank you. Now, so before going for a time series analysis, its terminology is totally different from the rest of the data science. Thank you, Namrata. So these terminologies, let me explain first. There are three things. One is seasonality, second is trend, and third is unexpected events. These things needs to be understood first. Now, what is seasonality? Seasonality means while predicting a time series data, there are certain months in a particular domain where the output value is at a peak as compared to other months. For example, I'm a brand similar to, say, Monte Carlo, right? Monte Carlo is known for selling winter clothes, right? And if you see its sale during winters, maybe November, December, January, the sale rises. Every year, if you see out of the 12 months, during this 3 months, the sale rises. So what we can say that there is a seasonality. So during this particular season, the sale rises. Maybe I'm an ice cream selling company, so maybe Quality Walls or have other ice cream selling brands. If you see their sale rises during April, May, June, July, right, or August, though people love ice cream in winters also, but the number is quite less. So you see for them, the seasonality is somewhere else. Electricity uses, if you see electricity uses, the electricity uses in summers increases because people start using AC, fans, right? So for them, the seasonality months are different. So seasonality means a particular time period when there is a regular increase or decrease in the pattern. It is not only always increasing, it could be in the reverse order also. For example, what could be the decreasing here? If you see what things decrease consumptions in terms of winters or in terms of summer, there are certain products whose consumptions decreases. So you can take that also. For example, cold drinks, the consumption of cold drinks decreases during winters. So you can take this in other way also. Now, second, no. For example, if you observe the data of tour and travels companies for last 3 years, and you see that in November and December, the distribution would be very high due to holiday season or festival seasons. So this talks about, again, one type of seasonality. Now, what is trend? Trend is one of the important factors which describes there is certainly increasing or decreasing a trend. So if you see the graph, we see that the graph is going up, 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 up. So we say that the sale is increasing. So this increasing is a trend, right? If the graph goes something like this, then we say that there is a decreasing trend, there is a fall, right? So if you can have a trend which is either increasing or decreasing, then that also needs to be catered in a time series analysis. Now, and there could be certain events which are unexpected. You never expected those events, and those events are also occurring, and how to handle them, that is again a challenging task. This is one of the most challenging tasks. As an example, just you see, it could be any business model, it could be any time series analysis or predictions, but nobody expected COVID to be there. And when COVID came, everything was down or almost still, right? So this is one of the unexpected events, a natural calamity or fall of something, or charges of corruption, or a decrease in the ranking by some of the world organizations, right? Or defamations, or loss in the trust of the leader. So it could be any such event or the hype created by the media, which may either increase or decrease, like it happened with the Maggie, right? Maggie case, where the Maggie was stopped and people shifted to other alternatives of it, right? So that was something which was never expected. So you see, these three things are part of a time series, and we have to identify these individual components. We have to counter them before drawing any conclusion on it, right? We have to counter them. We have to bring it in a state where the effect of these components can be nullified and we can have a model, right? Similarly, there are certain things called constant mean, rolling statistics, window size, exponential smoothing, right? Now, now time series are generally described in two modes or two types. One is additive time series and another is multiplicative time series. An additive time series is the one where you see the time series value is sum of these components. Base level. Base level means the mean of the values, right? Base level plus trend, increasing or decreasing, plus seasonality, plus some error, also called noise, right? Now, multiplicative is multiplication of these terms. So you will have to see which series we are and how we are going to deal with them. How to know which one is additive or multiplicative? Let us skip it. Exponential smoothing. These things we can skip for the time being. Okay, stages in a time series forecasting, visualizing time series. Whenever you have the data, visualize it, plot it, and let us have a look at it. Then stationarizing a time series. What is this? This is one of the most important thing. Stationary time series is one whose statistical properties such as mean, variance, autocorrelation, etc. are constant over time. So they do not change. So if you have a time series data where these are changing, then we will have to work on this data and we have to make it stationary. This means any time series data which is there, we have to make them stationary, and after making them stationary only, we can perform other tests. There are a lot of statistical tests that we do here. Now, once the curve becomes stationary, then find the best parameter for our model. We have to find out certain parameters for our model, and when those parameters are found, we can use those parameters to build our final model. And these parameters come from two plots called ACF and PACF, autocorrelations and partial autocorrelations plots, right? So this is something which we will be doing. What is this plots? We will see the difference between the two. The difference between the two is that in autocorrelations plot, we compare the current data. In autocorrelation, we measure the correlation between a series and its lagged values. Especially, it measures the correlations between time series at time t and its values at t minus k for all the values of k, where k is called a lag. What does it mean? Suppose I am analyzing yearly data, right? And suppose I'm analyzing winter data only, so that the sale of woolen clothes. Now you see the sale of woolen clothes increases in November, December, and January. Now, so if I have to compare it, the correlation, then the correlation or the time lag. So if you see the periodicity, I'm analyzing annually. So this periodicity has to be annual. Right. But if something which we are analyzing, such as number of customers coming to the restaurant, right, during 24 hours, so we may expect that the customers are coming in the night. So our periodicity may not be yearly, right? Our periodicity may be in the evening, night. So if you analyze the 24 hours of data, hourly data, then the lag could be in terms of hours, and the lag value could be 24, so that it repeats after 24 hours. So that lag has to be key. Now in auto correlation or ACF, you see this correlation is done for T minus K period. For example, if K is 12, so the current comparison for current month will be done with all the previous 12 values. Right. For example, current month is April. So I will start comparing with April, May, June, July, August, September, October, November, December, January, February, March. So this correlations has to be with everybody. But in PCF, this comparison or correlation is with exactly previous April, not with all the components of T minus K F till now. It is only T minus K, right? So this is the difference between the two. Fitting the model and predictions are some of the things. Let us try to fit one. For this, we will have data set, and the data set that we are going to have is, 1 second, I will show you a data set for time series analysis that we are going to use today. And that data set is machine learning folder, time series. And so this is a popular data set that we use, and this data set is electricity consumption. So you see here, month-wise, right, we have the electricity consumptions value, right? And we are going to analyze this time series data, and we will try to predict what would be the future demand of this electricity consumption. So you see how much data we do have. We have around 398 data plus column 397. And for its analysis, I'm going to use something called Google Colab. So in order to use Google Colab, let me do one thing. So I hope all of you know Google Colab. Google Colab is an online web-based ID or a notebook or a page given by Google Research Laboratory for running these Python programs on their cloud, right? So if you go and write colab.research.google.com, then it opens a page something like this, right? Of course, this is the data set that we will be using. But apart from this, I want to know this colab.google.com. And once you go here, how to do it, cancel it. So this is the default page when you go to colab.research.google.com. And here we should create a new notebook. So this is a new notebook that we are going to create. So once you create a notebook, you get a notebook like this. This is called IPython. Its extension is IPy notebook, right? So here, every library that generally you install on your computer with the pip command, you need not do that. Everything is available. You write simply print and you write any command that you want, and you click here to execute it or press Control Enter. So this is an execution cell that we use here. And you see here in the right hand side, when you execute your first command, so here it takes some time to initialize, and after the system is initialized, you see it gives you certain resources. And right now you see the version is Python 3 and I have been given 12.68 GB of RAM and around 28 GB of space. So it is much better than most of the systems that we have, right? Or most of you might have. But the only disadvantage of this is that you should have an active internet connection, right? But yes, for a learner point of view, you can use it. But when you work in a company, your data is very sensitive and you may not like to expose it. Recently, you might have heard that while using ChatGPT, also an engineer from a particular company exposed certain critical data of the company itself, right? So whenever you are using something without paying, right, there is no free lunch in this world. And if you are not paying, you are the product. So your data, whatever you are doing, they have access to it. It cannot be that nobody will allow you to get themselves used for free. There is no charity. Right. So Google Colab should not be used, but for learning purpose, for a budding data science engineers like us, you can use it. Now, so here you can have it, any packages that you want to import and you want to write, you can always simply import NumPy as NP, right? And simply it will get imported. Or if you want to write import Pandas as PD, and you run it, it gets imported, right? So this is the first step. Now let us try to see where is our data and how to load our data. So in order to load our data, let me call it a test notebook. Okay, and let me go here and I will write locate in drive. Locate in drive. So it will tell me where my current notebook is. So my current notebook is here, my drive Colab notebooks folder, right? And here we have all the data and the files that generally I use. But if you want to upload the new data set, upload file, and you browse and use the data set wherever we have your data set or something. Where is the data set? Maybe time series, maybe electricity consumption data. Is it uploaded? Here, elect consumption.csv. Elect consumption 1.csv, since there was other versions also of this, right? So already this data exists. Now, how to use this data? So import pandas and PD. Now, in order to make this data available, just to see, I uploaded this data into my Google Drive. I have uploaded this data into my Google Drive. One second, please. Okay. So I have uploaded this data into my Google Drive, and how should I read it? Being a CSV file, so how I will be writing? For that, I need to import certain special packages, and one of them is import from Google.colab import drive, and then I write drive.mount content / drive, right? I believe this is it. So let us run it. And once I run it, just all of you please look at it. This is important step. So once I run it, you get a pop-up screen like this. Permit this notebook to access your Google Drive files. So it is asking for a permission so that I allow it so that my Google Drive contents can be accessible by this Colab Research Laboratory. So I'm allowing it, connect to Google Drive. It will further ask permissions that which email address you are using. So I'm using this current email address. And in this email address, again, it's a lot of rules. And finally, I have to keep allow. And once I allow, it executes and it has access to my Google Drive. So let us see, it is still processing. and mounted. My drive is mounted in this location. Now next, once it is mounted, Pandas I have imported. So let me load this data, and this data I can load it like this. DF stands for a de facto name for data frame. PD dot read underscore CSV. CSV is the read CSV is the function to read the data from a CSV file. Had it would be in an Excel file, then I would have written read underscore Excel. Now I have to give the file location. So file location is first contained, then drive, then my drive, then collab notebooks, then the name of the file. Name of the file is elec consumption dot CSV. Let me have a look at the data that I have. It is consumption elec underscore consumption dot CSV. So collab notebooks. So it is case sensitive also. So consumption elec consumptions. Let me run it. If everything goes fine, then the data is loaded. Now let me have a look at it. df.head. Right. So if I write df.head, then till now you see this is the data that has been loaded into this notebook. So till now everybody is clear, I hope.
Sir, Vidita Shahad is right.
Pardon?
Hello.
Yes, please tell.
Sir, actually, can we get this data set? Will you provide this?
Of course, we will provide it at the end.
Data set with us?
Right, yes, yes.
Oh, okay.
We will provide it.
Okay, thank you. Yeah.
So you have learned what are the steps involved in doing this?
Yes, sir.
Okay. So now we have done it. So let us see some of the other things. df.shape. It will tell me how many rows and columns are there. Columns are, of course, 2. The data is this df dot is null dot sum so no null values, so no missing values. Almost the data is complete right now. So we have done it. Now let us come to the notebook, which is already written, and a lot of explanation also have written here on these notebooks, which is available. So let us try to see how we are going to clean it. So here you see in the actual notebook, I have imported NumPy. I have imported Pandas. I have imported Matplotlib.pyplot as PLT. Now this is for numerical calculations, right? We use NumPy because they are faster and they take less memory space in comparison to your Pandas sequences. During regular course, we do the test and we try to prove why it is there. Different programs we write to judge it and prove it. Matplotlib is a default or basic plotting library, and it's a submodule pyplot, which is used for plotting. So this is a very standard command. In every code, you will find these things written as it is. Though you can change this NumPy, PD, and PLT, but they're standards. Standards in the sense that there are 2 types of standards. One is called de jure and another is called de facto. So people start using it like this. Every programmer uses this by the same name. So we are also going to use it by the same name. And if you find these variables somewhere else also, you understand that their purpose is this only. After that, for this Matplotlib, if you see, there are certain styles related to color, theme, and other things. So they make it beautiful. In PyLab package, again, there are certain objects called RC parameters. They are used to define the parameters of the plotting in terms of font, color, size, etc. So you can define with the help of RC parameters. Next, this step already explained to you. This step already explained to you. Shape, print shape. The shape of the data is 397 by 2. top rows. These are the rows. Now, you see in these rows, what are the column names that we have? So let me see. In order to get the column names, okay, let me execute this also. Otherwise, intermediate cases I will not be able to run. So let me run these cells also. So again, this notebook is getting initialized. I don't need this notebook, so let me close it. So this is done. In the next notebook, I'm remounting it. So again, permissions are required. Every time you run it, okay, you might have to give, you will have to give permissions. And mounting is done. Then done. Now you see here how many columns are there. So you can write df dot columns, right? And once you execute it, you will get the name of the columns. So in my case, as it is seen here also, date and value, but in certain cases, the number of columns could be quite large. So you can write df dot columns. So it tells that the column names are like this, date and value. So it doesn't suit me. I want that this value should be actually consumption. So I want to rename this column. So one of the ways to do so is df.columns is equal to new set of values. So as a list, I'm providing the column names, right? Thereafter, I'm writing df is equal to df.na, drop na, not a number of values. But since I checked, this code is not required, because immediately here I checked this also. Df dot is null dot sum, how many of them are NS. So I will find that there are 0 null values. So okay, this step is not required, but generally we perform it to drop those incomplete rows. Okay. Now, since you see, looking at this date, what do you conclude? It is in which format? Let me show you the Excel sheet. Looking at this, it is in which format you see? DDMMYYY?
Yes.
Right. But actually, this is a text data, right? How do we do that? Let me do one thing. Df dot. So you see here, date is taken as an object over here, right? And this value is a float. So explicitly, we should change it to the date time. So you see here, PD pandas dot to date time. So I'm converting to date time. What I'm going to convert? This column, which has only df values. So column values in this pandas are represented like this. Let me give you one more thing. So df dot a column value can be written like this, maybe a single quote or a double quote, and date as it is written. It is case sensitive. So this is for top few values. I may write like this only. Okay, so you see a column can be referred like this. Okay, or a column data can be referred like this also, or you can simply refer a dot date. So we may refer it like this also, right? So both are same. So here you see df dot date. I'm giving the date column only to this and telling it that you convert it or format it is in a date time format and store it into date. Store it into the same object date column. So column is replaced after formatting, so that we do have the same thing. Now, columns, again, consumption column has been changed. Now, if you see the data which we have printed here also, there are 2 columns in only my data. Column date and value, as per the original data, date and value, right? But when you look at here, you find something called index also. Can you see here this number 0, 1, 2, 3, 4? So this is called index, and it is generated automatically starting from 0, 1, 2. You can explicitly change also when you import a data, right? But this we are not requiring it. And this index data is used for uniquely identifying a record. So a record can also be accessed using this index position or index data. Okay, now since we are using a time series data, so one of the beauty of time series data is that we do not require this indexing. We do not require this indexing. Our indexing has to be on the date data. So how to do so? So in order to do that, we can write df.setIndex, right? And we want this on which column? We want it on the date column. Now you see the date is in small case. Why it is small case? Because in this line, I have changed the date to small case, right? Do I have some message? Okay. Okay. Vijay Prakash gave me, please zoom it a bit. Naveen, okay, let me zoom it. So you see now, I think it is visible, right? Naveen and Sani, yes, my Google Colab is not working. So please ensure that you are logged in with your Google account. It will work. Yes, you can use Jupyter Notebook in the similar fashion. Please zoom it. Okay. Okay. So I have the messages now. Okay. So now you see, with this command df.setIndex, I'm changing the index on this date column, right? And I'm writing this in place is equal to true. Why this in place is equal to true? If I do not do it, they do the changes and return a copy of it. So if I write this attribute in place is equal to true, the changes are done and reflected in the same data frame, right? And let us see the first 5 rows through the df.head command. So this is my new format, you see. And you can see some change in display also. So earlier, whenever I used to print this date column, you see here, it was displayed like this. But after execution of this, you see it is displayed like this. So year first, then maybe date, and then month. Now let us try to visualize the data, because when we deal with the time series data, the very first task is to visualize the data, how our data looks like. So we have the Matplotlib, and I have already imported this PLT you see here. So matplotlib.pyplot as PLT. We will use this PLT object to print or plot. So let us see how to do so. So here I'm going to plot it, and it is plt.label, x label. So x-axis data. So x-axis data, I'm giving it a name of data. plt.y label, on y-axis, I'm giving consumption. On title, production graph or consumption graph. Basically, it should be consumption graph. And finally, plt.plot, and the data that I'm giving is df. Df has only 2 columns. One is the date, and then there is the consumptions. So first value is taken as an x-axis, and second value is taken as a y-axis. So let me run it. Hope I ran others also. No, I didn't run this one. So I should have run this one, and then I should have run this one. Otherwise, okay. So consumption graph, the changes reflected. Now we look at this data. This is the data that we are looking at from 1984 to 2016. And looking at this data, we can say that this data is already increasing data. So increasing data means already you can see some sort of a trend in it, and that trend is increasing. This means there is a increase in the consumptions of electricity, right? And here I have some notes also. So let us see what are these notes related to this diagram. Remember that for time series forecasting, a series needs to be stationary. Yes, we discussed it, but what does this stationary means? The stationary means that they should have constant mean, variance, and covariance. So looking at it, do you feel that if I take a mean of any k terms, are they going to be constant? If I take 5 years of data and next 5 years of data or next 5 years of data, are their mean going to be same? No. In this diagram, it will not be same. So we can say that this curve is not stationary, right? So we cannot perform anything on this, and we have to make this curve stationary. And that is the challenge that we are going to tackle. Now, look at it. The series should have a constant mean, variance, and covariance. There are few points to be noted here. The mean is not constant in this case, as we can clearly see an upward trend. The trend is increasing. Hence, we have identified that our series is not stationary. We have to have a series to do time series forecasting. Okay, so now let us try to make it a stationary series. But before that, there is another plot apart from this normal plot, a scatter plot, and you can plot the same series in this way also on data points rather than line plots. So this plot is a line plot where every data point is connected in sequence. Okay, but here you see only data points are marked by the dots. So if you want to have a look at this, then again it can be in this way also. Then there is another plot that we generally do that is called the density plot. So now this density plot and or this plot, if you see, I have not used Matplotlib. Here I'm using DF. DF is again data frame, which is part of a Pandas. So Pandas also allows you directly to plot certain data rather than explicitly using a PLT command. For example, here in the previous case, I used PLT command explicitly to plot it, right? But you can use most of the functions directly on the basis of data frame also. And apart from that, later on, if you are comfortable, you can use Seaborn libraries also, and they are damn good and most popular. So here df.plot and df entire data frame is plot and the style is k dot. So it is for dots again. But for showing, you need to show plt.show. Okay. Now, again, there is something called density plot or KDE. So you see here, df again data frame dot plot. But this time, an additional thing that I'm specifying is KDE. KDE talks about the density distribution. And generally, we do it to have a look at it if the data is normally distributed or not. Because most of the mathematical or statistical models or machine learning models assume that the data is parametric and the data is normally distributed. So let us have it seems to be normally distributed, quite similar to the bell curve. Now, as we have seen in the beginning that a time series has certain components. One second, got some message. Okay, thank you, Mohit. So now, given time series is thought to consist of 3 systematic components, as I told you: level, trend, and seasonability, and one non-systematic component called noise or error, whatever you call it. Now, these components, what they mean: level is the average value in the series, trend, the increasing or decreasing value in the series, seasonality, the repeating or short-term cycle in the series, and noise is some random variations. Now, in order to perform a time series, we may need to separate these components. We need to separate these components, and our primary goal is to make this series stable, right? Stationary, so that mean, variance, these components are these attributes are simple, same. Now, in order to decompose that, there is a package called statistical models.tsa time series analysis .seasonal, And from this seasonal submodule, we want this seasonal underscore decompose module to be here. And we are using seasonal underscore decompose model. We are passing it our data set frame called DF. And which model we want? We want the multiplicative model for decompositions. So after decomposition, it gives data in form of a result. And this result, we are directly plotting it. A data frame, we are directly plotting it and plot and show. So what do you look at it after plotting? See how many components has come up out of that result. Many components. This is residual. Yes, this residual refers to error, residual errors, as most of you know. So this refers to certain errors or noise. Now, this is the seasonality component. Now, if you look at it, since this graph is quite condensed and it covers data of almost 32 years. So if you see, this seems to be that every time during a season, the data goes on a peak and there is again a fall. So peak, fall, peak, fall, peak, fall, peak, fall. This is a seasonality that at regular interval, at regular seasons, they are repeating. Right. So there is seasonality in it. And you see, this is the seasonal axis, and it is evident from this also. Now, another component is called trend. So you see trend also. The trend is again increasing. So consumption is increasing. So there is trend in the data. This is also a valid thing. Oh. Okay, so after having a look at it, these are the things that we, and this is amplitude, right? Now, clearly there is an upward trend and a recurring event where electricity consumption shoots maximum every year. So this is evident. Now, stationarizing the time series, we have to make it stationary. Now, how to make it stationary? This is a bit tricky. So let us talk here about a very popular test, a statistical test that we do to check this. And this test is known as ADF. What is this ADF? This ADF is called augmented Dickey-Fuller test. Dickey-Fuller test is one of the most popular statistical tests. So if you are aware with the statistics, you know what kind of statistical tests are, right, and how we write them. So we are going to have a look at it now. It can be used to determine the presence of unit roots in the series. What are unit roots? And hence help us understand if the series is stationary or not. The null and the alternate hypothesis of the test is, what is the null hypothesis? The series has a unit root that a value of a is equal to 1, right? Those who do not have fundamentals in statistics, or they have not gone through statistics. So in statistics, there are certain tests, and these tests are called hypothesis tests. And there are two things. One is null hypothesis and another is alternate hypothesis. So it happens something that we make a statement as a null hypothesis, and null hypothesis is generally a fact which is known to us already, right? The average salary of doctors are, say, 2 lakh rupees per year, and this data exists for the past 4 or 5 years. Alternate hypothesis is something which we want to test whether this new thing or new claim is true or not, right? It could be that the salary of the doctors has changed, right? So the mean salary is no more this the 2 lakh rupees, or the salary has increased or decreased. And on the basis of that also, we write something called null hypothesis. So you see here on the similar basis, the series has a unit root. The series has no unit root is our alternate hypothesis. Both are generally contradictory. Now, so if we fail to reject the null hypothesis, if we fail to reject means we cannot reject, this means this is true. We can say that the series is not stationary. So if this is true, null hypothesis is true, then the series is not stationary. But we want our series to be stationary. This means the series can be linear or difference of the stationary equilibrium. If both mean and standard deviations are flat lines, the series becomes a stationary. So in order to make the series stationary, what we need, the mean and the standard deviations should be straight. Okay, now let us see the next step. Here we are writing this add Fuller test, and during this process we will be calling this test multiple times, right? So we have written it as a function, and how we have written it as a function, let me explain you. थोड़ा सा tricky है, but don't be afraid, I will explain every line of it. Oh, okay. Now you see here. So from states model, time series analysis, state tools, another submodule, and from that we are calling this add Fuller module. Now here I'm defining a function. So in Python, a function is defined by the keyword called def, right? The name of the function, test stationarity, and the data that we have, we pass it the data. Yes, any questions? Yes, Ranjit, you want to say something? Sorry, you are not audible. Okay, let me try. But once I zoom it, where is my pan? I cannot slide it. Can I? If I zoom this, can I? No, I cannot slide it. I cannot slide it. After zooming, I'm unable to. My panning tool is not visible. Okay. No, this is not my panning tool. Okay. Let it be up to this only. So you see here, I'm telling, so def, the name of the function, I'm creating a user-defined function, test underscore stationarity, and the parameter I'm giving. Now, we have to define the rolling statistics. Now, what is the rolling statistics? Something which is moving and calculating. So one is mean and the standard deviations. So if we have some data like this, and we want to move the calculate the rolling statistics, and if my k value is equal to 4, this means for 4 months, I will calculate the average. So this is first value, maybe A1, average one. Next could be for next 4 months. Next could be next 4 months. Next could be next 4 months. Similarly, I get A1, A2, A3, A4, and this is called moving or rolling averages, right? So rolling statistics, if you see, my data is time series object, time series dot rollings for a month of 12. Okay, this means 12 values. Take the mean and take the standard deviations. And let us store it into an object called rolling mean, roll mean, and roll standard deviations. Now, let me plot this. So first with the PLT, I'm trying to plot time series, the entire data with blue color and the label as original data. Then I plot rolling mean, okay, red color, and the label is this. Then I plot rolling standard deviations, color is black and label is this. And then I plot the legends at a location which is best for them. Title is rolling mean and standard deviations, and show is block is equal to false. Don't put the blocks. Now, what I do from this plotting, if you look at the graph, whenever I pass a data, it plots a diagram like this. This diagram is plotted. So original data is in blue color. Rolling mean, you see mean, this mean is here. Now, why there is a gap in the beginning, this mean? Any idea? Any idea why there is a gap? Okay, this gap is because if you see, we are taking a value of k. As I told you, if there is a data like this, and if my k value is equal to 5, so I will take average of 5 values now. So first average will come at position 5, right? And for this 4 values, there will not be any average. So here it would be blank, right? So you don't find that moving average for the first k-1 values. So first 11 values you see in this diagram, it is blank, right? So it is not available there. Next, let us, so I hope this part of code is clear, what it is doing. Is it clear, this part of code?
Yes, sir.
Thank you. Thank you for the response. Now, let us see how to perform the test. Now, perform Dickey Fuller test. So, AD Fuller, this is the function which I have imported, right? And we pass it the entire data, the consumption part, and there is some attribute called auto lag. We call it AIC. AIC, what is AIC? We will discuss later on. So we give this parameter and we get an object called ADFT. Now this output of DFT will give us without defining what values are. Hence we manually write the values. Does it explains using a for loop? So let us do it. What are the values? This object has a lot of values. Okay, and we will extract some values from it and we will print it. So what values it is going to print? It is going to print some values like this, which is printed at the bottom. So few of them we will explain in this class. So what are those values? pd.series ADF 0 to 4. This means 0, 1, 2, and 3 values you pick from this list. Okay, so you pick first 4 values with the index position 0, 1, 2, and 3. 4 is not included. And give them an index like this. Index means here you say the names. Test statistics, p-value, number of lags used, and number of observations used, right? And you store them into the output. And for every key comma values in this dictionary.items, try to print the critical value, certain values we are printing, right? Now, if you see this value, then these values are something like this. Test statistics is negative, minus 2.35. P-value is 0.18, 18%. Number of lags used is 15. Observations 381. Critical value 1%, 5%, 10%. Leave it. Now, whenever we do a test, a hypothesis test, this is the most important thing. It tells us whether the null hypothesis should be accepted or rejected. We would have been happy if the null hypothesis is rejected. Null hypothesis rejected means the curve is stationary. We wanted to make it stationary, right? But as we can see here, the curve is not stationary. It is increasing. Rolling standard is somehow stationary, but you see rolling mean is not stationary. So our curve is not stationary, right? But anyways, this is from the diagram that we draw, but statistically, if you see, p-value is important. And we reject null hypothesis only if this p-value is less than 0.05. So we do reject null hypothesis when this value is less than 0.05. But in this,
0.5.
yeah, but in this case,
Yes,
higher than
we
that.
have to accept. Yeah,
Yes,
1 to 1.
yes. So you see here, so I have written a code also. So df of 1. So in this object, if you see at index position 1, we have this p-value. So if this p-value is less than this, conclusion, there is a strong evidence against the null hypothesis. Against the null hypothesis means we reject the null hypothesis, accept the alternate hypothesis, and the series is stationary. Else, which is the current case, there is a weak evidence against the null hypothesis and the series is not stationary, right? So we have done this ADF test and we have found that the series is not stationary, right? Now, let us conclude till now what we have done. We have loaded the data into Google Colab. we have indexed the value on date column. We have tried to change the data type of the date column, right? And after that, we have decomposed using stats tools function decompose. And by decomposing, we saw the mean, the trend, amplitude, and the noise. And we saw there was a trend. So we have to separate them. But before that, we have to make this curve stationary. In order to make the curve stationary, or to check if the curve is stationary or not, though it is clear from the diagram, right? But we do not go by that. We have to perform a statistical test, and that statistical test is known as a DF Fuller test. So a Dickey Fuller test. So Dickey Fuller test is again a function which is available in stat tools. And here I have explained you that calculate the rolling mean and standard deviations and try to plot this. And for add Fuller test, you see, you pass this data to the add Fuller function, and it gives you certain values. And on the basis of certain values, especially this p value, you look at it if the null hypothesis can be accepted or rejected. This is what we have done. Our purpose is that the p value should have been less than 0.05, but here it is not the case. It is more than 0.05. Okay, so now let us proceed to the second part. And the code the logic I have written here, let us have a look at it. Through the above graph, we've seen that increasing mean and standard deviation, and hence our series is not stationary. Mean and standard deviation. This is mean. You see, ये भी थोड़ा बढ़ रहा है, कम है, but फिर भी थोड़ा सा higher range पे है, and standard deviations तो बढ़ रहा ही है. So इससे भी देख के आपको लगता है कि it is not stationary. Hypothesis will be rejected once we get a value less than this. Null hypothesis will be rejected. We see that the p-value is greater than 0.505. So we cannot reject the null hypothesis. Also, test statistics is greater than critical values. What does it mean? This is test statistics, and this is critical values, at least the first critical values. So this test statistics is greater than the critical values. Is it okay? Or I'm telling you the reverse. Is test statistics value greater than critical value 1% or less? Is test statistics greater than or less?
Less.
Yes, Yuva?
It's less.
It is less, na? But actually it is greater than. Why it is greater than? Let me tell you. Most of us commit this mistake. So if you see our number line, integer number line or whatever it is, so you see it is 0, 1, 2, 3, -1, -2, -3. So higher values are on the right hand side, and smaller values are on the left hand side. So if you see -2.25 somewhere here, okay, this is test value, and critical value is -3 point somewhere here. So this is critical value. So which one is higher, test value or critical value? Higher values are always on the right hand side.
Test value.
So test value -2 is bigger than -3. It is a negative, so in negative it is reverse, right? So remember this diagram that anything on the right is bigger. So 3 is bigger than 2, 2 is bigger than 1, similarly. So you see this value is bigger than this, isn't it?
Yes, sir.
Right, this is what I want to say here. So ideally that should not have been the case, apart from this p-value. So slowly we analyze these things. So test statistics is greater than the critical values. So the data is not non-stationary, and we will have to make it stationary. So this is also another reason for it. To get the stationary Cs, we need to eliminate the trend and seasonality. So whatever the trend that is there, we need to extract that trend. Okay, now how to do so? So in order to do, we start by taking a log of the series. Log from function language. Now log क्या logarithmic है. So if we take the log, generally that trend reduces. If you take log of anything, the spread of the curve squeezes, right? So we take a log of the series to reduce the magnitude of the values and reduce the rising trend in the series. Then after getting the log of the series, we find the rolling averages of the series. A rolling average is calculated by taking input of past 12 months and giving a mean consumption. So we will go and take a log of this value. So how do we do that? So our entire data frame was df. So np.log df. Now we call this df.log, the new data frame. Data frame, logged data frame. And on this logged data frame, let us again call the mean, rolling mean, standard deviations. And this logged data frame, let us plot it. And then this plotting is in blue. Then we plot moving averages or mean with the red and standard deviation with the black color. So you see now the new graph. Can you see here? It is almost a straight mean. And can you see red here also? Earlier you see the spread of this red. How was it? It was starting somewhere at 60 and it was going somewhere here till 102 or 4. So from 60 to 104, a spread of 40. Okay, delta y was delta x was around 40, 42. If I draw a rectangle, a right angle triangle, and if I try to see this height was of around 42. Are you getting what I want to say?
Yes, sir.
Yes.
So it was highly inclined or the trend was high. But when I do here, when I come here, you see now this trend. This is first of all within 4 and 5, and that too fractional. That too fractional. So can we say that up to some extent we can see decrease in the trend, or the trend has been squeezed?
Yeah.
Okay, thank you. Now, after finding the mean, we take the difference of the series and the mean at every point. अब हम क्या करेंगे? Moving averages उसको minus कर देंगे. तो moving averages minus करने से average value निकल गया. So average value minus करने के बाद df log moving average difference and drop NA. So dropping N, and no, there is no NA, so we cannot, we should ignore it. Now, after this, we should again perform this Dickey-Fuller test to check statistically, if we have a stationary curve or not, right? So let us do it again, pass it. So test stationarity, and this object df log moving average difference is being passed to this function. This is the same function which has been designed here, written here earlier, and what we have been doing here. So once we pass it, similar output we will get in terms of the components which we have implemented in this function. So this user defined function is given, and now you see what kind of output are given. इससे पहले वाला output देखते हैं पहले. Earlier we got an output like this. This was the output when we did this Dickey-Fuller test for the first time. Can you see this? And now you see the second one. Now, what do you conclude from this?
P value is 0.
Mean and standard deviations, are they parallel?
Yes, sir.
Trend khatam ho gaya, inclination trend khatam.
Yes.
Right? Okay. So now you see. Okay. What is the P value now?
0.05 se less.
Less than 0.05. So 5% less. Very happy. Now, what about the test statistics and the critical value?
Test statistics is less than critical value.
And in earlier case, it was higher.
Greater than.
Higher. Very good. So we are able to get a stationary curve. Conclusion, there is a strong evidence against the null hypothesis. The series is stationary. Right. Now, let us come here. From the above graph, we observe that the data attains stationarity. Now, one of the method is completed. As we come to conclusion, we need to check the weighted average to understand the trend of the data in the time series. Now we need to go for weighted average. As we started this lecture, I told that how should we calculate. So I showed you a diagram, something like this. And I suggested two things, that you take a mean and you take the average of two values, or you take a weighted average. So here we calculate the weighted average now and their mean. So now df log dot EWM is called exponential moving averages, and we give it a lag of 12, minimum periods 0, adjustment is true, and we calculate the mean. This is called weighted mean. Now what we are going to do, this weighted mean, the exponential moving average is a weighted average of the last n prices or n transactions or n points, right? Where weighting decreases exponentially with previous price or period. There is a decrease in the weight. जितना पुराने जाएंगे पहले जाएंगे उसका value कम होता जाएगा weight का, right? In other words, the formula gives recent prices or readings more value, weight. Now, previously, we subtracted df log with the moving averages. Now take the same df log and subtract weighting averages now. So let us subtract the weighting averages. So you say df.log subtract weighting averages. So averages हमने weighted averages subtract किए, and again let us go for the Dickey-Fuller test. So again go for the Dickey-Fuller test, and can you see something else here? Now what we got? So let us see. Again, you see the value, p-value is still less than 5%, and this test statistics and critical value, they are close, and the curve is still stationary, right? So from the above graph,
But sir, here the mean and the standard deviation is not parallel.
okay, let that be. The parallelity is not important here. Something else is important over here.
Okay.
Right? Something else is more important than that. So what is that? From the above graph, we observe that the data attained stationarity. We also see that the test statistics and critical statistics are relatively equal. So these statistical values should be equal. They should not be far away. They are more important than what you see here. Right, parallelity. So anyways, they are not straight lines, so they will not be parallel, right? But they are their average. If you try to see their averages, then the averages may seem to be parallel, right? Parallel is not a very strict requirement for this. Now, there can be cases when there is a high seasonality in the data. Even there could be cases which are worse than this. Right. In those cases, just removing the trend will not help. We have removed the trend by weighted averages. We need to also take care of seasonality in the series. One such method for this task is differencing. And differencing again can be first level, second level, third level differencing. Depending upon what kind of thing we have, we do the differencing. Now, how we do the differencing? Differencing is performed by subtracting the previous observation from the current observations, performing Dickey-Fuller test once again. So differencing means, for example, if I have a data from January, February, March, April, and it continues, then you subtract the data of February from January. Or you do the reverse one, you move forward. You subtract the data of January from the February, right? So you put this data here, sorry. So suppose this is our data, first, second, third, fourth, fifth, sixth, like this. So differencing, if I take a differencing of 1, So you subtract this from this and give it a value, D1. Subtract this from this and you get D2. Subtract this from this and you get D3. Okay, this is differentiating. Now, this differentiating can be on 1 level, 2 level, 3 level, right? To find out the seasonality if it is more, right? So let us see what differentiating we have taken here. So whatever we do have the data, df.log, just I'm printing it for your sake, that the first month data is here, right? Now, df.log shift head, I'm taking the first differentiating. And when I do the first differentiating, the first value will be 0 and not available. Does it make sense? Why it is so?
Yes.
Yes.
Okay, very good. And second one, thereafter it continues. So now you I did it for showing you. So df log minus df log dot shift, first differentiating and I've taken, and then try to print the data. So can you see now something after differentiating?
Yeah.
Can you see this getting more straight?
Yes.
Yes, sir.
Okay, so rolling mean is more straighter. Now again go for the Dickey-Fuller test. So here, test for stationarity, Dickey-Fuller test. You go for the Dickey-Fuller test, and the Dickey-Fuller test statistics are here. This is test statistics, and p-value. You see, p-value is. How do you read this p-value? Can we accept or reject null hypothesis?
We have
पहले तो p-value
to
कम था, अभी
reject
बढ़ गया ना?
Yeah.
p-value बढ़ गया, पहले 0.017 कुछ था, but you are not looking at it properly. Look at it properly. This p-value is e to the power
minus 0.9.
So now it is a bigger value or a smaller value?
Smaller value.
Smaller.
Smaller value, much smaller than this value which we are expecting, right? So we can accept that null hypothesis is rejected and the series is stationary, right? Okay, now, so finally we have made it stationary. Now, the next step is to perform decomposition, which provides a structured way of thinking about time series for forecasting problem, both generally in terms of modeling complexity and specifically in terms of. Yes, God bless you. Yeah. Yes, please tell you want to ask something? No. So you see, let us go for the next step is to perform decomposition, which provides a structured way of thinking about a time series forecasting model, both generally in terms of modeling complexity and specificity in terms of how to best capture each of the components in the given model. Finally, we perform this Dickey-Fuller test again. So you see here, seasonal decompose, we will decompose it. Okay, so seasonal dot decompose, from this log data, we are decomposing it. In the first time, we decomposed it from the original data. Now we are using an additive model and frequency is 12. And whatever the result we get, we plot it. Now let us see the result. After decomposing, the components look like this. Okay, now plot what this a trend, store trend in the trend, drop NA, seasonality into seasonality, residual in residual, and residual dot NA into here. So after decomposition, we look at the residuals when we have clearly a flat line for both the mean and the standard deviation. So mean and the standard deviations should have a flat line. We have got our stationary series, and now we can move to find the best model for our parameters for our model. So if you see the residuals, they are also very much on this line. And from the test that we have, this df.log. I think there is some mistake here. We should have been doing on this. This is our final data, no? Rather than df.log. We should be doing it on this data. So I have done some mistake here. Let me correct it. Oh, since I didn't execute it, intermediate codes, so I forgot to execute it. So anyways, let me see till how I have executed. Where I stopped executing the code here. So let me go for it. Run everything after this line. And let me see what is process it. We have done it. Why not this one? What says frequency? Oh, why this frequency is not matching? Because it was working for df this earlier while I was doing it. Something I missed. I don't know why it is so. Anyways, I will fix it up that later. Oh, why this? Anyways, I will fix this later when we resume this task tomorrow. So after this, till now, our purpose was only to make the curve stationary, right? But we have not identified the parameters which are needed for our model. There are certain parameters, also known as parameters P, Q, R, which are there. And what is ACF and PCF? How to plot that, and from them how to get certain plots, right? Those things are there. Those graphs have also vanished anyways. So I will fix this, why it is there. So when we resume this, our time series analysis second part tomorrow, we will learn the main part of it. And that main part is after making the curve stationary, how to get these values P, D, and Q. They are very tricky looking at the graph, how to conclude that. And on the basis of this only, we make a model, and that model that we use the primary model for time series analysis, that is called ARIMA model, auto-regressive integrated moving averages model. So how that model can be used to do the predictions. And on the basis of this, how can we predict the electricity consumptions for maybe 2 years, 3 years, or 5 years, right? And after that, we will see what are the limitations of this ARIMA model. And these limitations are covered by a model like SARIMA. So that we will discuss. We will also discuss advantages and disadvantages of both the models. And more important thing is how to decide these parameters which are important for modeling, that is P, D, and Q. And that will take time. So I don't want to cover that still in this 10 minutes remaining. I will not be able to cover that part. So this is where I would like to stop this time series analysis part. Any questions till now, or if somebody can summarize it? If somebody can summarize it for me. What we have done. Can anybody summarize this for me? No one to summarize?
Yes, sir. For time series analysis, we taken some data between a time like of as an example, we can take any company. If
Right.
any company want to sell any product, or if he want to uh, do the how many production I have to do the product. So he will look the backup data, how many in the previous year, if he is making purchasing a stock or the development stock for the year, upcoming year. So he
Very
will
good.
take the back year data and he will analyze how many the product has been, goods has been sold to market and people have taken that. So according to that data analysis, he will make plan for his future, like
Very
for
good.
future selling. So this thing happening so for that purpose we are going with a time series analysis, and using this in this time series analysis we can use in technology system as like for the forecasting of anything, like according to the data, previous data, some forecasting is coming for the weather related, sometimes some earthquake related. These all things happening due to the previous data. There is some time series analysis is happening on the previous data. According to based of the result of that, they are saying like in upcoming 1 hour or upcoming 2 or 3 months, you have to face these climatic changes. That's it from my side, sir.
Yes, Aswani, you have well explained the usability of this time series data, in which cases it can be used, this time series analysis. But you will also find that people are using naive Bayes and KNN also for
Yes, sir.
predicting this kind of cases, right? But
Yes.
the thing is that you should be very clear which model is to be fitted where. Right.
Yes, sir.
If you
Yes.
know only regular machine learning techniques, not time series, then it is a very dangerous thing. There is a very good saying that if hammer is the only tool that you have, then every problem in this world to you will look like a nail. So
Yes, sir.
apart from those machine learning algorithms, you should learn this that data science algorithms. You should learn this time series analysis also, and you explain the usability of this time series analysis. But I want if somebody can summarize what we have done in the code. Can somebody summarize what steps we have taken here in this notebook? What we have been doing here? What all we have done? You are given with a CSV file. We have opened the
So-
Google. Yeah.
So basically, we have just imported the library that is a Pandas library,
Very good.
and from the basically the repository, we have just used the feature into the data frame that is a read to CSV file,
Very
where
good.
through which we have just imported the data
Very
and
good.
hold it into a data frame.
Very good.
And using that data frame, basically we have just created a model which is basically related to the forecasted model.
Okay.
So the data which we have just imported, so there is a date-wise consumption has been given.
Okay.
So on the basis of that, we have just created the model seeing the past data which we have.
So
that
Anupji, I would like to correct here. So once we imported the data, we plotted it, and we tried to figure it out if there is a seasonality or trend in this. Then we
Correct.
decompose the data and try to separate the seasonality and trend from it, right? And we have not created a model yet. We can create a model only if this curve becomes stationary. That is the mean and the rolling standard deviations, they become constant. So in order to check if a curve is stationary or not, we go for a statistical test called Dickey-Fuller test.
Correct.
Right.
Right.
So we did a Dickey-Fuller test, and we had our own null hypothesis and alternate hypothesis, and the value which was greater than 0.05. So what we did, we tried to see, we took the log of the data and we squeezed it. Then we subtracted the rolling averages from that. Then we subtracted the weighted average from that. And finally, we have been doing this Fuller test again and again. Until the end, we were able to make the curve stationary. right?
Right,
This
sir,
is-
right.
Yet we have not made the model. Please note. अभी तक हमारा टाइम सीरीज का मॉडल नहीं बना है. अभी हमने प्रिपरेशन कर ली है कि बस अब गैस का चूल्हा मतलब आग लगाना ही है ताकि अब पूड़ियां छननी शुरू हो जाएं. Right. So tomorrow we'll
Right.
do this ACF and PCF and try to analyze those ACF and PCF graph. They are tricky. Say after that we will make the model. Model बनाना कुछ नहीं है. रिमा फंक्शन कॉल करो, वैल्यूज दे दो. बट वो वैल्यूज क्या है वो इंपॉर्टेंट है. वो आपने किस्सा सुना होगा ना कि एक कहीं पे जहाज थी और एक जहाज खराब हो गई थी. शहर के सारे इंजीनियर्स को बुलाया गया, सारे थक गए, तो एक बूढ़ा आदमी वहां से जा रहा था. तो बोला कि सर आप कहो तो मैं भी कोशिश कर लूं जहाज ठीक करने के लिए. तो बोले क्यों भाई, तुम क्या करोगे जब सारे थक गए? तो उसने एक हथौड़ा लिया, थोड़ा सा कान लगाया और एक हथौड़ा धीरे से मारा और बोला आपकी जहाज रेडी हो गई. अब उसके लिए उसने $1,00,000 सपोज चार्ज कर दिया. तो उसको पूछा गया कि भाई ये $1,00,000 एक हथौड़ा मारने का? तो बोला नहीं सर, हथौड़ा मारने का नहीं, उस हथौड़े को कहाँ और कितने ताकत के साथ मारना है उसके लिए वो है. सो एरिमा मॉडल इज देयर, कोई भी इसको कॉल कर सकता है, बट वो वैल्यूज PQR क्या है, दे आर दैट $1 million क्वेश्चंस. ठीक है. सो दैट $1 million क्वेश्चंस I will be answering you tomorrow and tell you how to find out that. Is that okay?
Yes, sir. Sure.
Yeah, thank you. So tomorrow do join us on time. Sanchita, if you have any questions or any participant has any questions related to the SkillEnable team is here. Sanchita is here. You can fill your forms, feedback forms. I think she has already shared in the chat window, right? At least share some details with them. They are organizing this for you for free and you are getting benefited from it. So give them some feedbacks. It will help us. It will help the SkillEnable to organize you more such programs in the near future, right? And topics, if you want, we can come prepared on these topics. We try to put it in a very simplified manner, all right? So that it is understood, implemented by everybody, all right? So certification details, if you want certificates, please fill the forms. These details will be used for the certificates. Post training program, the materials, recorded videos, everything will be shared to you, the registered participants. All right. So that's it from my side. Anything from the SkillEnable team? Or we can say good.
I hope everybody enjoyed the session thoroughly.
Yes.
Yes.
Guys, the form link has been shared in the chat. Please fill it up. And we would check if you have attended this workshop thoroughly and you have filled up the form, you'll definitely get the certificate for today. And we'll be discussing this topics that we mentioned for this workshop tomorrow and day after tomorrow as well. So it will be the same link. Please join with the same link in this workshop. Okay.
Can you please help with the tomorrow's topic?
We will continue with the same topic. We will conclude this topic and after that we will go for anomaly detection.
Okay. Thank you. Thank you, Mr. Nihar.
Thank you. Thank you.
Thank you, everyone. Thank you for your time. Fill up the form and then you can leave.
Thank you. And it was really a great session. Thank you so much.
Thank you, Srivani. Thank you for your feedback.
Thank you. I'll see you tomorrow. Thanks.
Sure.
Yeah.
Guys, please don't leave without filling up. Please leave, fill up the form and then.
Okay, thank you, Sanchita. Good night.
Yes, sir. Yes, sir. Yeah. Good night. We are ending the session. Thank you. See you tomorrow.
Thank you.